In this video, we're going to describe and explain how the properties of polymers depend on their structural features. First of all, just make sure you don't confuse the addition polymers with the condensation polymers in a question, because they do have, similar types of outcomes. Number one, a longer chain is going to equal stronger van der Waals because these are all molecular, which will equal a stronger polymer and a higher melting point. So that's sort of underlining some of the reasoning why. So if we look at the way groups are arranged, there's sort of another way we can think about how the properties are altered. So if we look at Kevlar as an example, depending how the Kevlar attaches, or how the polymers attach, we can end up with a cis formation where if you draw a line of axes down the carbon-nitrogen bond where the benzene ends up on the same side, we call that cis. In that case, it will look a little bit different than if we had them as a trans. So just to compare them at the same time, we can see here they continue in a straight chain. So there's some implications for that. Right here you could see that as they start to continue to link up, they're going to keep bending back up upon each other, and so they can't stack as close together. There's going to be large holes and gaps, and as a result we're going to have fewer van der Waals. So that's because of the way they're arranged. The trans conformation you can see here is forming a very straight line. You could actually put another layer above, and they'd get very, very close, and therefore they'd have strong van der Waals, and thus be stronger and higher melting point. The last way is cross-linking, and so this is going back to the previous video of C.8.3 looking at when phenol and methanol used. So just to remind ourselves, taking two phenols and two methanols, one of the methanols will join at the second carbon and the other one will join at the fourth carbon. And before we only looked at what happened with this one reacting with another phenol, but now we can look at, well, what happens if they polymerize with each other. And so what you can see happening is that we end up with, in some cases, them polymerizing at two positions, and what they end up is forming sort of these cross-linked structures. And so the implication of that is that the stronger covalent bonds in the cross-linking, because actually they're being held together by actual covalent bonds versus van der Waals, so we're going to get stronger, more rigid plastic with a higher melting point. So this is just going to continue on the structure like that.